Okay, back from the break. On to some cache tier improvements. Talking about hit set and proxy write. Looks like this is you, Sage.
Yep. So the general theme here is just the cache tiering and how to make it better. The whole bunch of work was done over the hammer cycle by the Intel team to improve cache tiering. Most of it was focused on the read side. So I think we're doing a much better job on reads of avoiding promotion if we can, doing those promotions asynchronously, and proxying the reads through the back end. The last piece of that, which is actually written but didn't make it for Hammer, needs to be tested, is the write proxy, which will also proxy writes through, and so we can defer promotion. The bummer is that when you do actually decide to finally promote, you still have to block writes because the object is in flight, can't write to the backend one, you can't really write to the cache until it's promoted. So that isn't really going to go away, but I think we're sort of most of the way to good there. So pretty happy with that. So the first step obviously is to just get that going in there. But so the secondary set of things is just then based on that infrastructure, making much better decisions about when we want to promote based on reads and when we want to promote based on writes. So we sort of limit the amount of times that we're pushing things between the base tier and the cache tier because it's expensive. So a couple different ways that I think we can approach that. The first is to take the recency thing that we did for reads, where you have to have multiple reads before you promote. Do the same thing for writes. The problem with that is that it's a little bit limiting in that it's very, very coarse grained. We're tracking whether or not we got an IO on an object over some time period, where the time period is like an hour. And so we know whether there was one or more IOs in the last hour and whether there's one or more IOs in the hour before that, and so on, which is better than no information, but isn't necessarily the information that we want. And there are, I guess, a couple of different ways that I think we should try to address that. The first is to pay attention to the different types of IOs. So I think reads and writes obviously are different. So if we have an object that's getting lots of reads but never written, maybe we don't want to promote it at all because our backend tier handles reads just fine. Or maybe we are getting writes but no reads, and depending on what the performance profile is on the two different tiers, it might be important. The other scenario would be where if you have a write through cache, meaning that on reads after enough reads you promote into the cache tier, but if you get any writes, you would just delete it from the cache tier and push it back down to the base tier and do the writes there, which I hear from the DM crypt folks at least seems to work pretty well for a lot of workloads. So that would be an option too. But in any case, being able to know whether or not we've been getting reads or writes on an object would be really, really useful. The other sort of dimension would be whether the writes that we get are sequential or random. Would be good to know, because if it's always like full sequential writes on the object, then it might as well stay in the base tier. But if they're random, then we'd want to pull them into the cache tier. So I think that the easy way to address that would just be to extend hit set to have a bunch of different arguments to all the different functions when you insert something, so you know whether it's a read or a write, or it's maybe a sequential read or write or something. Keep track of that, or you can make the implementation just basically keep in two parallel hit sets, one for the reads and a different hit set for writes, something like that. Right. So that's I think the simpler part of the proposal, and I'd be curious to hear what everybody else sort of thinks of that, whether that makes sense for the workloads that they're sort of thinking about for the cases of cache tiering, or whether it doesn't make sense. Any questions or comments on that so far? Okay. So the second half of this And the one that's sort of less well-defined but more complicated is how we can just make hit sets better. So the real limitation is they cover a sort of fixed time interval, say an hour, and they only tell you whether there's one or more. They don't tell you how many. And there's a huge difference between an object that was read once during an hour and one that was read, 100,000 times during the hour. And right now we have no way to tell the difference. The recency thing we did means that the first read we won't promote, but the second read we will. Or maybe the first hour of reads we won't promote, but the second hour, as soon as we hit 1 hour, then we'll promote, which is better than nothing, but is still pretty coarse. So it'd be nice if we could sort of detect, tepid objects versus hot objects. So I have a couple. The main idea I have here is to use some sort of hybrid combination of a hash table and a Bloom filter. So the idea is that you would capture the hot stuff in the hash table, and you would capture the stuff that's not very hot in the Bloom filter, where it's more lossy, and hopefully, figure out when to move it from the hash set to the Bloom filter when you're doing that. And if you're looking at the pad, I have a couple different ideas on how to do this. Are you here, Sam? Have you looked at this yet?
Yeah, I'm trying to formulate a counter argument.
Yeah. Okay. Well, let me go through just the simple option. So the basic idea is that you have a Bloom filter that you put the cold stuff in. You'd have a map of a hash table of object name, or maybe the hash of the object, I don't really know or care, to the count. That's the hot set, and you also have a similar recent set. So for every, say your overall interval is an hour, maybe every minute you would collect a bunch of stuff in the hash table, and then after that minute, you'd basically take everything that is above some median or threshold number of items and put that in the recent count. So that's sort of the hotter, warmer objects to get an explicit count, and everything that's below some threshold, you just dump it in the Bloom filter, because if it's only had like the difference between 1 request and 12 requests doesn't matter that much. But if you have 10,000, then it's sort of the hot one. And then you just repeat that over the course of the hour. And over that period, all the cold stuff would end up in this Bloom filter. It's all cold. And the hot stuff would have an explicit count. And then your policy decision could be, if it's depending on how hot it is, or if it's in the hot set and not the warm set, I guess, then you would do a promote. So maybe on the 100th read.
Sorry. Go ahead.
Yeah. So then you're so the difference would be the promote decision on read, for example, would say after I've seen 100 reads on this object, then I'll promote it, but the first 99 I won't, or something, as opposed to the second read I'll promote it. Yeah. I'm not sure how accurate it actually has to be. Like, it's something really simple might be good enough. So I started. Oh, go ahead.
I was going to say if we had an estimator for what the 90th percentile hotness was, that would give us a background that we could. So the risk, I think, is that we have some kind of oscillating hot set where every M request or something, we have set A is hot, then set B is hot, then set C is hot, then set A is hot, then set B is hot, then set C is hot. So depending on the exact details of that pattern, you might get one particular set of objects showing up as very hot, while in fact the entire set was actually pretty hot, and you just ended up with one particular set chosen somewhat arbitrarily, which is, well, for one thing, it's not necessarily a problem that that's selected as hot, because it just means that'll be in the cache, and if it's that even, you weren't going to win anyway. But I'm worried that there's some. Go ahead.
I think the chunky this option 1 actually captured that, because it's over a long interval, like an hour, and you keep adding them into recent. Or sorry, into the hot set.
It depends on how big recent is and how fast the requests are coming in. If they're coming in fast enough, then you don't have enough. You'll be knocking stuff off recent constantly. If it's not big enough to capture the hot component.
Yeah, but every time you knock stuff off recent, you put it in hot. That accumulates over the entire hour. And maybe
Sorry, that's what I meant. Oh,
Okay.
it doesn't accumulate over the whole hour. It gets knocked off as it runs out, right?
You have 2 hash sets. One of them is cycled every minute, and every minute you take the top percentile and you dump it and you accumulate it over the course of the hour.
that one you don't trim.
That one you maybe you would trim it if it got too big, because it's hard to tell how big it is, how big it should be.
If you don't trim it, I think it works.
Yeah, I mean, even if you did and you trimmed it, yeah, I guess, yeah, right. So okay, so a corollary of this was that that paper that we saw at FAST that was estimating it's something curve. It's like the minimum miss rate curve.
That was it.
Estimating that, which basically tells you how big these sets should be. So I think that would be a really useful. It would be useful because it would tell us how big our cache pool should be relative to our overall pool, for one. It would also tell us within a cache tier how big these the hot set should be relative to this cold should really be called warm, I think. It's not cold. Right?
Yeah. There are actually approximate counting Bloom filters too.
That might be also useful.
Except that I think they overestimate and not underestimate.
Yep. So basically, what happened yesterday, I was sitting here trying to think of how this algorithm should work, the chunky window thing. And I had 10 different variations in my head, and so I tried to write them down, and I realized they're all kind of the same. But then I went and did a Google search because it seems like this should be a really standard problem, and it turns out there are 1 million papers published on this. So there were just 2 of them here that I found. But the basic idea is that if you have a stream of a bazillion data items, it will estimate what the most common ones are, like the top M or whatever. It'll give you an approximate set of what those are in sorted order. I went and started reading one of the papers, and it's like this weird. It's like hashes of hashes with a hash set, whatever. It's all crazy. It reminds me of Bloom filters, but in 3 dimensions. So probably we could just sort of find an implementation of one of these, or go pick an approach and but I think the main thing is that we could just go do some reading and probably find a good solution here.
ACM wants to sell it to me.
Yeah, that was really annoying. I was going to put a snarky comment in the Etherpad, but didn't. Yep. So, you got it. Okay. So right. So I guess there's sort of 3 things here then. I mean, there's I mentioned at the beginning we should just take all the right proxy stuff that Zhiqiang already did, and the write recency. That's all. Just get that in there because it's simple and it works. But there's a question of whether we want to have this. We want to track reads and writes, and maybe sequential read and sequential write independently in this, those independent dimensions. Is number 1.
Wait, what does sequential read and write mean for a Rados object? Just big or small?
That's part of the question, I guess. But the basic idea being that if all we ever see are large sequential reads on the entire object, and then maybe we never want to promote it. But if it's random reads, then maybe we do. It's easy. And similarly for writes.
Big versus small seems like a reasonable proxy for that, I think.
Yeah, actually, yeah.
And it seems like that's what we're looking for.
Small write. Or maybe we distinguish between write versus append. Like whether they're overwrites versus.
Actually, we can.
but we don't know.
Well, if you have small sequential writes, then necessarily they're pipelined, almost, kind of, right? So that means we already have state around for the object, so it would be pretty easy for us to notice that we just got 4 writes on the same object.
Maybe.
In which case we don't want to promote it. We just want to proxy it right back to the store.
Yeah. Unless they're too small. Yeah, I don't know. I mean, it's like there are a million things we could do to find like the coarsest things. I think the big ones are full sequential reads and full sequential writes. We want to make sure that those don't promote if we can avoid it. Like say we have 4 meg objects and we're reading it in 512K chunks. That's like 8 IOs. That shouldn't lead to a promotion if it's just doing it once. Yep.
But realizing that that's what's happening and not 1K reads randomly dispersed through the object, even in that case, it seems like you'd want to proxy it. That forgetting why we would ever not proxy a read.
Because the backend, because it's hot and the cache steer is just faster. It's better at random IO.
Yeah, and if it's a registry coded pools, yeah, okay.
Yeah, but honestly, maybe if we have these better counting hit sets, then if we set the threshold at like 100, then the first 99 random IOs will be just totally proxied anyway. So that might mask a lot of that anyway.
I think past your 20th read is probably time to go ahead and promote it, though. So whatever we use for the approximate reading, it needs to be accurate enough to
right
do a little better than that.
Yep. Right. So if we so one is just whether we track these independently, which I think makes sense. And there's sort of the question of whether we extend the hit set interface so that instead of just insert and contains, it's like insert of type and contains type. Or whether we just have
more
like
than one hit set.
Or just have more than one of them, right? But maybe the implementation is more efficient at storing 3 counters for each item as opposed to 3 totally independent maps. You know what I mean? Because if it's counts, literally the key is like more, although it's really just a hash value.
Well, if it's one of these approximate, crap, forgot the word.
Approximate counting Bloom filters.
Counting Bloom filters. They look like Bloom filters, and they do
weird stuff. Yeah.
Statistics on the buckets to make a decision about an estimator for a particular keys count. So it's not like the number of keys matters in that kind of. Well, No, it would have to simply store more than one of these Bloom filters or multidimensional Bloom filters.
Right. Okay. Okay, so that's the first thing. The second thing is I think we should have estimate the cache sizes, the MRC construction, because that'll be, I think, useful in a whole bunch of different ways.
Yeah.
And then the third thing is go and do some research and figure out which approach for finding frequent items and data streams we actually want to do. Because they seem like they're kind of perfect, right? It's using a bounded amount of space to estimate the set of items that are in the most frequent top n, whatever of m. Which is kind of what we.
Oh yeah, that's true. Counting Bloom filters actually don't get you that at all. So we would need one of these other techniques.
Yeah, you still.
Yeah, you're right.
Yep. Yeah. So unfortunately, it mostly means we have to go do a bunch of reading.
Wait a minute, couldn't you just generate like 1,000 just pick arbitrarily 1,000 hash values and query the counts on those? Or no, 1,000 well-distributed object names and query the counts on those. That would give you a representative distribution, and then you can use that to decide whether a particular one is in the top 90th percentile.
That's what MRC does, right? That gives you.
Oh no, MRC is different.
That gives you a shape.
No, I was just thinking to myself a way to turn a counting proxy or a counting Bloom filter into a tell me whether this one's in the top 90%. No, doesn't matter. Never mind.
Mm-hmm.
That probably doesn't work for some reason.
Yeah. Yeah. But it also seems that my sort of trivial thing probably would be half decent too, just as sort of a proof of concept. And it'll give you an actual count.
Actually, what we should actually do is implement a literal hit set that simply offloads into the level DB, because that'll tell us how well we can do if we have a perfect implementation.
Yeah.
If it doesn't get us any win, then we know to stop. More importantly, it'll get us some win, and that'll give us a way to evaluate how well the approximate one does.
Okay. Okay.
We actually finishing this one early?
Are you complaining?
Just surprised.